So today we are going to explode a capacitor. This is a DC aluminum electrolytic capacitor, and it is rated for 16 volts. The energy released is 1/2 CV squared. The capacitance is 1,000 microfarads, and the voltage is going to be 16 volts. That's the breakdown voltage. Then the energy released should be 0.128 joule. Power is the energy released per time, and so if we assume that this is released in roughly a millisecond, then that will be 128 watts of power liberated when this explodes. Here is the capacitor, which is connected to the power supply. The negative terminal of the power supply is connected to the negative terminal of the capacitor. We're measuring the voltage across the capacitor, which right now is 0 because the power supply is not on. Once this voltage reads 16 volts, above 16 volts, probably more like 20, there's going to be some type of explosion, hopefully, if we're lucky.
AcePhysics.org, Math and Physics Tutoring with Dr. Hudis.
12.6, 15.1, 15.2, 17.7, 18.9. Yep, keep going up. 20.4, 21.7.
This is significantly above the rated voltage.
22.5, 23.8.
Is this what you were expecting?
Short-term overvoltage could be high. Yeah.
Should I just let it sit here for a bit, or should I just keep going up?
No, keep going up.
Hello, I'm Dr. Jacob Hudis. If you need math or physics tutoring, please go to my website, AcePhysics.org, and book a lesson.